Alright, so today we're going to begin our second part of our discussion on areas of regular polygons. Today we're focusing on when given the information about the radius of the polygon. So, we want to find the area of each regular polygon for, in this case, a pentagon with a radius of 11 meters. Now, if you remember from our original diagram last time, we had the setup where we had the apothem, our y value, x, and then we also had this r. Again, the radius is r. So for this particular problem, n is still 5 because it's a pentagon, and r is 11. Now, the difference between this and the previous setup is that now I don't actually know the sign length. I need to go ahead and find it. I still want to find x the same way. X is still found by doing 180 over the number of sides, which is still 36. So we have this right triangle setup, where we have the r is 11, this angle is 36. We need to solve for the apothem and for this y value. Now, since the 11 is the hypotenuse, a is our adjacent, and y is our opposite sides, we need to set up two different trig ratios. One ratio to solve for a, one ratio to solve for y. Well, if I want to solve for a, since it's adjacent hypotenuse, we're going to use cosine. So cosine of the angle equals side adjacent over the side hypotenuse. So we cross multiply. A equals 11 cosine of 36. Which when you plug that in, you're going to get a value that is 8.899. Now again, make sure you store that one because you're going to need to use that later. Now our y value is found the same way, but since it's the opposite side, we're going to use sine. So sine of 36 equals y over 11, opposite of our hypotenuse. So we cross multiply. 11 sine of 36 equals y. So you'll find your y value is going to come out to be 6.466. Now, if you remember, your original area formula is 1/2 a n s. So I have n, it's given, I solve for a, but I need to get s. Well, not really. If you remember, our y value equals s divided by 2. So if I were to solve for s, I can plug that value into here and just have the equation in terms of y. So if the area equation is 1/2 a n s, and area equals 1/2 a n times 2y then, because s is equal to 2y, well, what's a half of 2? Just 1. So an alternate formula you can use, and this will work for anything really, but works best for the regular polygons where you don't know the actual side length, is just use area equals the apothem times the number of sides times this y value right here you're going to find. This allows you to simply plug in without having to find s first, because remember, y is not exact, so if you doubled it to find s, you then have to store it as a new variable to use it properly, and there's no need. So instead your area is the apothem, 8.899, times the number of sides, which is 5, times the y value, which is 6.466. This is a very similar shortcut to how we rewrote the rhombus equation, the 1/2 d1 d2 as 2xy instead. Very similar idea. So we're going to get our area as 287.695 meters squared. So again, just a little recap. We are given the n and r values. We need to plug that in to still solve for x. We always have to solve for x for every single area problem. And then we need to solve for the apothem and the y value. Where apothem, since it's the adjacent, we use cosine. The y value, since it's opposite, we use the sine. And I can rewrite my area equation, 1/2 a n s, as just a n y, Annie. And then we just plug in the a value, n, and y to get my answer. So let's take a look at another one. So our hexagon, again, like with the side length ones, is also a very special problem. So r is 16, n is 6. So our x value is 180 divided by n, which is 30. So we're going to create another one of our special right triangles. So if that's 30, this one's 60. So this y value right here, since it's opposite 30, is half of the 16, because that's opposite 90. So y is really just 8. And then if this is 8, our a value is always that value, square root of 3. So our area is the apothem times the number of sides times the y value. When you work that out, you're going to get 384 square root of 3 feet squared. So it's a very similar concept. In fact, you're actually going to find that the radius for a hexagon is equal to the side length of a hexagon. Because again, if y is 8, and I double that, I get 16. Notice, side length, radius, both the same for a hexagon. So you can look at it either way. It's still the same concept though. R and n is given. We find x. A and y are set up very nicely. So hexagon's the only ones that happens for. All other shapes you're going to have to actually solve a right triangle trig problem. Like this one. So our octagon has a radius of 8.2. So again, our radius is 8.2. If it's an octagon, that means n is 8. So our angle is 180 divided by 8, which is 22.5. So we set up a right triangle, our apothem, y, radius, and then angle. That's better. So again, still the same setup as all the other radius problems. Now it's not as special. A is the adjacent, so cosine of the angle equals our apothem over our hypotenuse. When I cross multiply, A equals 8.2 cosine of the angle 22.5. When you work that out, you're going to find A is 7.576. And again, make sure you store that one exactly. We have to solve for y now. Y is opposite the angle, so it's sine. So sine of 22.5 equals y over 8.2. So when I cross multiply, I get y equals 8.2 sine of 22.5, which when you work that out in your calculator, you're going to get 3.138. And again, make sure you store that one as well. Both of those are inexact answers. So our area is the apothem, 7.576, times the number of sides, times the side length, times y, which is 3.138. So again, making sure you're using the exact values for those two, not typing them in, just using the exact variable. We get 190.183 inches squared. So again, it's just a right triangle trig problem, very similar to how we set up the right triangle trig problems last time. Only now we're given radius. And again, radius is this side length right here. The angle is found by doing 180 over the number of sides, solving for a and y. A is the adjacent side, that's why it's cosine. Y is the opposite side, that's why it's sine. Once we get a and y, your area is a times n times the y value. So why don't you go ahead and do this one on your own. Identify n and r. Use that to set up your right triangle. Once you get x, set up your two trig ratios to solve for a and y to get your area. So go ahead and pause it while you work that out. Okay, so you should have identified r as 3.4, n is 24, which told you x was 180 over 24, which is 7.5. So you set up your right triangle. Here's your angle. A is adjacent, y is opposites, and the radius is the hypotenuse 3.4. When you solve for them, a is 3.371, y is 0.444. Then your final area when you plug into a and y is 35.903 centimeters squared. Now, a couple things. First off, you should start noticing as the number of sides gets larger and larger, a much bigger side here, much angle right here, the apothem and the radius will both get very, very close to each other. They'll be almost the same number after a certain while. And this value down here, we can keep on getting smaller and smaller and smaller. The difference between this and the apothem is going to be huge. Notice 3.371 versus 0.444. Looking at something that is something like 3 times as big, essentially. Well, not quite that much, but enough. Well, sorry, not 3 times, 9 times is what I meant to say. Probably more like 8. Anyway. Now that's it for Chapter 11. So your homework for this section is 11.4b. If you go on the portals, you'll see when we have our next quiz and test. Don't forget about the Chapter 11 review sheet as well. At this point, you know everything you know how to do to solve on that review sheet, so make sure you're working on those problems, getting ready for the test. And I will see you in class.